Hello everyone, welcome to In 5 Minutes. In this video we are going to see the next type of numerical methods, that is Euler's modified method. So in our previous video we saw the problems on Euler's method. We have calculated the exact value and that exact value is not equal to the approximate value. So we need the exact value to be approximately equal to the value which we calculate using these methods. So this is the Euler's modified method which take care of such things. So here also first initial we will have the 5 steps. These 5 steps are exactly similar to Euler's method. That is, we represent our given equation in dy by dx, that is f of x comma y. Okay, then we will write the initial conditions, that is x of 0 equal to something at y of 0 equal to something. We will be given that find the value of y at x equal to something. Okay, then we will given the interval. So then we have the number of steps, m is x minus x0 upon h. Remember here the number of steps is represented by m. If h is not given, we can calculate the value of h from this equation. If number of steps and h both are not given, then assume the number of steps as 2. Okay, always remember, if the number of steps are not given, we have to assume number of steps equal to 2 and then we can calculate the interval h. After this, we will draw the table. So in Euler's modified method, here we have the 2 steps, so we will have 2 tables. So this table is for step 1, this table is for step 2. Okay, so table 1, table 2. So this is the difference between Euler's method and Euler's modified method. So we will first calculate for step 1. So this is our step 1 and this will be our table 1. Approximate number n. N is the number and it is not the number of steps because number of steps is represented by m. So m is 1, 2, 3, 4 and so on. It can go up to anything. Okay. Then we have y1 the whole raised to n. What is this? This indicates that y1 at the first step. Okay. Then we calculate Sn. Sn is nothing but f of x1 comma y1 of n. Since this is the first step, here we will write y1 x1 y1 the whole raised to n equal to something. Then y1 n plus 1 is nothing but y0 plus h by 2 s0 plus sn. Sn is here. How to calculate s0? So here we have some basic steps which you should also follow in step 1 also. We will be given at x equal to 0, which is initial condition. We have y is 0. We find s of 0. S of 0 is f of x0 comma y0 and f of x comma y we get from here. Okay, so we calculate s0. x1 will be x0 plus h, y1 will be y0 plus h s0. From here we will get y1, from here we will get x1 and from here we will get s0. So what will be this all y1 the whole raised to n? Y1 the whole raised to n will be y1 the whole raised to 1 and this value will always be equal to y1. Okay. Then here we calculate s1 equal to f of and y1 value we get from here. Okay, then we calculate s1 equal to f of x1 comma y1 1 equal to something. Then here we will get y1 the whole raised to n plus 1. N is 1, so we get y1 of 2 equal to y0 plus h by 2 s0 plus sn. N is 1, so s1. So from here we will get y1 of 2. Then y1 of 2 value, this value we take here. Then we calculate all this, we will get y1 of 3. Remember here we will have y1 and x1 only. Okay, so we take this y1 of 3 value here. We will continue to do this when we get this value, that is y1 of n, and this will be y1 of n plus 1. We continue to do this when this value matches with this value. Okay, so this will be our step 1 and from step 1 we will get the value of y. This will be the value of y at x equal to something. So this will be the value of y at x equal to something in step 1. What we are going to do in step 2, because we are given the 2 steps. So in step 2 we are going to follow the same procedure. Step 2, same procedure. But in step 2, this value which we got, y and x, will be the initial value. Okay, initial value means x0, y0 will be this value in second step, and we follow the same procedure. Okay, so this will be more clear when we see the problem on this. So the problem on this we will see in our next video. So stay tuned for our future lectures.